Have you ever been driving and wondered what's the max speed that I can travel before my car slides off the road? Well, let's derive an equation for that right now. So you have your car traveling around this curve within a radius of r. Let's first draw out our free body diagram. So we're going to obviously have our force due to gravity and our force normal. And the only thing keeping us on this road is the frictional force between the tires and the ground, force of friction. And so we want to know what is our net force here. Well, in the y direction it's 0, but the x direction we have the friction. So the force due to friction is equal to the net force, but the net force, since we're going a circle, is the centripetal force. And so we know equations for friction and centripetal forces. So the centripetal force equals the mass times the velocity squared over the radius. And the frictional force equals the coefficient of friction, which in this case we want the static friction, because we're not sliding on the ground. Every time it's rolling, we're only contacting at that one point. So we actually want the static friction, not the kinetic, even though we're moving because we're not sliding, times the normal force. But we know that the normal force just equals the gravitational force as shown in the free body diagram. So we have mass v squared over r equals this coefficient of friction, mass times gravity. These masses will go ahead and cancel out, and we can rearrange this equation for velocity, and we get that the max velocity you can travel is the square root of the static friction, the gravity times the radius. If you want a more in-depth video on this concept, there will be a full-length video in the description.